You guys all got the Adrian sent all of you the pig roast invitation. Yes, no? Please do. Please do.
If I
If you
come, I'll
didn't
have to miss a class.
have
Just
to
so you
miss
know.
it on Saturday.
I'll have to miss either a Tuesday or Thursday class to come on Saturday, just because of my work
Oh,
schedule.
okay. Well, if you can swing, people come and go all day, well into the evening. I think Noah Gilchrist is probably going to be there about 9 o'clock at night. So people come and go all day.
Okay.
Now I'm going to ask you guys for numbers. If the numbers are if I see that the numbers aren't going to work, I'm going to change them. Just let you know in advance. We still might need to modify them after we get a little bit into the problem because um, well, that's the danger when I get numbers from you guys. Okay. In other words, the example might not work. We might have to tweak something. I'm just letting you know in advance so you don't think I don't know what I'm doing, which I guess wouldn't be too far from the truth, but maybe not so apparent. Well, I just somebody complained that sometimes examples don't work, and I'm like, well, I could just teach the same example semester after semester and not solicit input from you guys. Would that be better? Yeah, well, that's kind of my point, Esteban. So, um, A is the event they are taking a humanities, arts, that kind of thing. Okay, sound good? You guys have to take one elective in there, right? Right? Don't you have to take a humanities elective or?
Uh, is is religion a humanities?
Yes.
Then yes.
Yeah. A lot of you take world religions. A lot of you take. Is geography a substitute for that?
No, that's a separate.
Okay. Okay. Language. We could even call English college comp language arts, which would fall into this, right?
Technically, that's separate, but for this purpose, we can do that.
Yeah. 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 What's the probability that a randomly selected student, and let's talk, I don't care where we talk. Let's talk main campus LCC. Okay. You guys have been there, right? You guys physically know what's there. Know what's physically there.
Yeah.
Talk to me. Okay, so there's like business majors, there's engineering technology majors, the technician stuff. There's physical science, there's psychology, there are all sorts of. I think there's 160-degree programs. I think something like that. It's ridiculous. So, what's the probability that a randomly selected student is currently taking an arts and humanities class? Think business people, they're a fairly sizable bunch at the college. I'm not going to check, guys. Just give me a number.
Oh.
0.3 maybe? 1 and
Okay.
3? Sound good? Let's make it 0.4. If you count like the language arts and um, the actual arts, right? And the humanities, like world religion, that sector. You know, those majors are always taking an arts and humanities class. So, those are always there. So anyway, and everybody else probably has to take one elective in that field, I would think. Um, what do you want? What else do you want? Math?
Sure.
What do you want the probability that a randomly selected student is taking a math class? Now, remember, again, um, I guess I wouldn't count business math. We're talking algebra, elementary algebra, algebra, the calculus sequence, any class in those, trig, and any class like that. And I'd be shocked if pretty much every major didn't require at least one math class as well. What do you think? 0.7? How about if we go 0.6? Can we do that? 0.6? Because remember, your nursing students or your physical science students probably some of those programs probably just require one math class, so they're one and done, and throughout the rest of their college, their 2-year degree, they don't take any math classes. There are, and it's an incredibly good program. They used to have a 2-year waiting list. I don't know if they still do. I wouldn't be surprised if they do.
Who-
So, did she get her nursing degree? How hard was it for her to get a job? There's a waiting list to get into the program. She probably got a job right out of college. Probably. They have a really, really strong and well known nursing program, both RNs and LPNs. Um, uh, what other type do we want to talk about? Maybe science? Yes, no? And we'll include engineering in the sciences. Does that sound good?
Yeah.
But we can't call it science because we'll get confused with the sample space, right? We can't call it S. We can't call the event S. So how about if we call it T? I originally had T here. You want to call it T for technology?
That's okay. Yeah.
Any better ideas? I don't know. So, technology and science. There, it makes sense now, right? Now you have to remember the business people may not take any science courses at all. The business majors probably don't require chemistry, right? They probably don't require any physics. I pretty much guarantee that. I'm not even sure they require any general science. So, like the business guys probably don't take anything. Obviously, the engineering and engineering technology students do. They would take science. Um, some people consider psychology a science. Some call it witchcraft. I don't know. I think there's some validity to it, though, as a science. Um, your nursing students definitely take science courses, right? Pretty much. That's
Yeah.
probably half their curriculum. You wouldn't argue that, would you? Biology, obviously, chemistry, obviously. So, what's the probability that a randomly selected student is going to be taken, if we ask, a class that we would consider technology or science. What do you think? Talk to me. Guys, this is not a test.
I was thinking
Wait.
higher than that.
How about if we go 5, 1/2?
Yeah.
Do you think that's possible on some planet in a galaxy far, far away? Mm-hmm.
I mean, science is so vague, it may even be higher than math.
It probably is. But for our example, I'd like to use all different numbers for this. And I'd like to keep the numbers down so that the unions don't become ridiculous, in the 0.9 range. Okay. So coming over here, here's our scorecard, okay, guys? Probability of A equals 0.4. Probability of M is 0.6. Probability of T, 0.5. And I should change my marker color so that they are distinguishable from what I just wrote. Sorry. Let me rewrite those so it's obvious that they're a little bit different and stand out. That's different. You can see the difference, right?
Yeah.
In color.
Yeah.
P of A, P of M, P of T. Brian, I'm trying to convince Josh. You know Josh, right? And Estevan and Kenny probably already know this or may already know this. I'm trying to convince Josh Van Dyke, the lab instructor. Oh, Estevan knows who he is. You know Josh, don't you, Brian? He's a couple years older than, further along in the program than you.
The name's not ringing a bell.
Really, he's always in the Sun Lab. Anyway, he's getting married after he graduates in December. So I'm trying to get Josh, and his fiance is Lucy. Well, I tried to tell him that they didn't have to wait till December for the wedding and reception. They could just have it at the pig roast. Okay. All right. At least one of just hear me out, gentlemen. At least one of the invitees of the folks that attend is usually is an ordained minister or is at least licensed to, marry people. At least one guy is usually. So, check, right? Yeah, plenty of witnesses.
Mm-hmm.
Check, right? Plenty of food for the reception. Yes, no? Brian, you've been to one, right?
No, I haven't actually.
Oh, God, I could have sworn you were there a couple years ago.
I always end up working.
Oh, that's a bad habit to get into, my friend.
Well,
but I understand.
Yeah.
Trust me, if you go away hungry from the pig roast, you got nobody to blame but look in the mirror. Okay. Plenty of music, right? Brooke's going to bring her karaoke machine, which when some people sing is arguably music, but that's beside the point. I didn't say good music, okay? And we got a 22-acre dance floor. What more could you ask? You got everything.
My rent paid?
Well, yeah, but for a wedding for Josh and Lucy to get.
Oh, I thought you meant me skipping work.
No. So I don't. I mean, and we could for the ride after the wedding, right? we could take them on a hayride, right, to the backfield, right,
That's
while
what we
while everybody's getting the decorations up for the reception, in the gazebo kind of thing. We could hook a couple of 55-gallon drums to the hay wagon, like they do the tin can thing. I really and think about the cost savings. How much does a wedding cost these days?
too much.
20 grand? 10 grand? What's that? I think it is. I do. I mean, and that's for an average wedding. You're probably going to shell out between 10 and 20. I think that's what my daughter did. And actually hers was a little bit above average. Anyway, so I know we shelled out quite a bit. So yeah, I think it's 10 to 20 grand. 10's probably a smaller, 50 people kind of thing. So you're gonna spend 10 grand or more, or the cost of a side dish. Let me think. Let me do the math here. Anyway, we'll see.
Oh,
Lucy's actually
him. I just found him on LinkedIn.
who? Josh?
Yeah.
You
I
know
had to see a
Josh.
picture.
Yeah, Sam. Sam's getting married in June. I'm going to work on him too. Um, so they don't want to do the wedding at the pig roast, but I'm trying to convince them to at least do a pre-reception. Okay. We got to work on intersections here, guys. What is the probability, do you think, that if we asked a randomly selected student if they are taking a math class, that they respond that they're taking, I'm taking a language arts kind of thing, or religion or theory of music or something like that, or choir, right? I'm taking one of those, and I'm also taking a math class. What is that intersection? Give me a number. A quarter, maybe?
2, yeah.
0.2? How about if we make 0.22 to make the math interesting? What's the probability of math and technologies?
Point. You want to keep the numbers down? It's like 0.7. Oh, no, it can't be that high. It'd have to be like
it has to be less than or equal to 0.5. Yes, no?
Yeah, so it'd have to be like 0.4.
I would buy that. How about if he goes 0.37? How's that? Does that work?
Yeah.
Probability of I'm thinking. Okay. What's the probability of arts and technologies? I'm kind of thinking this might be a little bit lower. Maybe in the teens. Right? Because arts is 0.4, technology is 0.5. How many students are taking world religions and a technology course at the same time? You guys might. Not sure a chemistry major will. Or at least the probability isn't very good. Business major, forget it, right?
Yeah. So maybe like.
So maybe in the teens, do you think? 0.15 maybe?
Yeah.
How many students, what's the probability that some guy or gal, right, is going to respond that they're taking, oh yeah, I'm taking an arts class, I'm taking world religions, and I'm taking chemistry or physics or something like that, or anatomy like a nursing student. And I am taking, college algebra or Calc 1 or something like that. All three. What do you think? I'm kind of thinking in the single digits.
I'd say 0.05 chance.
Yeah.
Okay.
Very low.
Now, so we have our scorecard, don't we? We can have all sorts of fun today. We're probably going to milk this example for the rest of class, or at least a good portion of it.
Didn't you just miss a 0 at the bottom?
Shoot. Yes, I did. I was making sure you guys... One or the other, right?
Yeah.
I was making sure you guys were paying attention. Okay. No, absolutely not. Absolutely not. Nope. And I'm going to show you how all this works. All right. Ready to roll? Now we got some numbers to figure out. You ready? Talk to me.
Yes.
Hallelujah. What's the probability that a randomly selected student is taking either an arts class or a math class? This time it's union. Yes, no? Talk to me. Right? Either one or both, right? How do we do it? We know from the last time, right? Probability, and I think Estefan or somebody already said this, probability of A plus the probability of the event M, that's a math class, right? Minus the intersection. Do you see why I asked for the intersections? What do you get? Two? Subtract 2. Talk to me. Since we have our scorecard here, can I erase the stuff in blue?
Yes.
Going once, twice. Saves my back too. So I'm going to bring our work up here. That way it's not sitting out there in the middle of the board. And we know why we are subtracting off the intersection, right? Right? We proved that the other day.
You don't want to double count the football.
You don't want to double count the football. Oh, by the way, I forgot to do the Venn diagram. How about can I erase important dates? Yes, no?
Yes.
Talk to me. Going once, twice. Okay, here we go. Do we have everybody today? Okay, Chris isn't here. Right. I know Kenny's not going to be here.
I'm here.
Oh, I'm sorry. I missed your name, Chris. I'm sorry.
Yeah, I was like 10 minutes late.
Okay, I'm sorry.
That's fine.
So here's the Venn diagram, guys. You want to do arts in red? We're going to do arts in red. Do you want to do? What do you want to use for math?
Purple.
Okay. You
Okay.
guys got to talk to me. That's math, right? Actually, let's make math a bit bigger. Generally,
Yeah.
guys, when you do the Venn diagrams, you try to make, what do you want for technology? Green? Would green work? Blue?
Let's get weird. Do
Pink?
orange.
Hot pink?
Oh
Hot
yeah,
pink?
that's the one.
Now, can you distinguish hot pink from the others? It really
Kind of.
doesn't matter. They could all be the same color. Does this work? Got to talk to me, guys. Come on. So technology is 0.5, but that refers to the entire circle, right?
Hmm.
Arts is 0.4. Math. You guys have to my wife to thank for these colors, okay? Otherwise, we'd be down to the red, green, blue, black. 0.6. Actually, you guys should thank my wife for me being able to teach, really. 'Cause I couldn't do it without her. Trust me, she gets mad sometimes. So, what's the area? This football here. I hesitate to outline it. This is the intersection of all three, right?
Hmm.
What we say that was 0.5.
Oh, there's a special name for that shape too. I can't think of it right now.
I have zero clue what that name would be.
I'm thinking of, rotary engines, how they have that weird.
Yeah, they call them a
There's a name
Wankel
for
engine.
that. Huh?
Wankel
Yeah.
engine.
Yeah, there's a name for that shape.
Is it related to the cycloid?
It's been a while.
Something like this.
Yeah.
A triangle with rounded sides instead of straight sides. There's probably a name for it, but I have no idea what it is, and I'm sure the equation for it is pretty nasty. It does, doesn't it? Yeah, the cycloid, in case anyone doesn't remember, if this is the valve stem on a bicycle tire, right? As this tire moves forward, this valve stem, the position of this valve stem, right, is gonna follow something like this, right? Well, actually, it won't do that. It's more like this, right? Something like that. Maybe not that exaggerated, but it's going to be something like that, right? And then it's going to repeat, right?
Hmm.
That's the cycloid. And the expression for a cycloid is not for the faint of heart. I don't remember what it is, but it's definitely got some squares and I think cubes in it, I think. Maybe even force. So anyway.
Pronouncing it wrong, but I believe it's a Rulex triangle.
How do you spell it?
REULEAUX triangle.
AUX, right?
Yes.
I have no idea how to pronounce that. It sounds French.
Yeah, I was gonna say it could be like rouleau.
Yeah, rouleau triangle. Yeah. Okay. All right. Okay. Interesting. I've never heard that. I've never seen that or heard that shape had a name. I'm not surprised it does, by the way.
Oh, do you know anything about rotary engines?
A little bit.
Okay, well,
Little bit.
I didn't want to get into like a story
Yeah.
of it.
They're better for wear and tear. The only thing you have to worry about is the apex seals,
Yep.
wear and tear wise, I believe. With pistons, you have to worry about the piston rings and the piston bearings. It's a lot easier on the mechanical stuff. But the apex seals are what fails in them, right? I think.
Correct.
Does Mazda still make a rotary engine for their sports cars?
No, the apex seals were too unreliable.
Okay. All right.
They just did it for the higher rev range.
Way back in the day when I was in school, I worked at a until I graduated, I worked at a computer engineering kind of digital automation kind of thing. In fact, it was called digital automation in Bowling Green while I went to school in Toledo. And one of the engineers there had a Mazda 7, I think. No, RX-7, right?
Yeah.
RX-7. Yeah. And it had a Wankel engine in it. And he said, yeah, I'm going to have to replace the apex seals pretty soon. Oh, okay. What are those? So he told me all about the rotary engines. That's really about the only reason I know about them. Okay. So guys, this is the intersection of all three. This football shape is the intersection of A and T, arts and technologies. This football shape, the purple and the red, is the intersection of arts and mathematics. This purple shape, this football shape is the intersection of math and technology. Okay. All right. Now, these football shapes, all three of them, right? There's three of them because there's two event intersections. They all include the intersection of all three. Okay. All right. Does everybody understand that? This is important. Yes, no?
Yes.
What's the probability of let's find the unions first, then we'll talk about that later. Let's get the unions of the two event unions, and then we'll do the 3 event union, and I'll give you the theory of that. I'm not going to do the proof. I'll just show you on the Venn diagram. Deal?
Okay.
What's the probability of A union T? Isn't that 0.4 plus 0.5 minus, what's the intersection? 1.5? Do you buy that?
Yeah.
What do you get? 7.5? Yes, no?
Yes.
What's the probability of math or technology? Well, that's probability of math, 0.6. I don't know why I keep doing stuff like that. Probability of math, 0.6, plus probability of technology, 0.5, minus the probability of both, because we count it twice, 0.37. What do you get?
0.73.
7.3?
Yeah.
Okay. So what did we find on the Venn diagram, guys? What's the first one? Arts or math? Isn't that this figure 8 region here? Yes, no?
Arts or math?
Yes, no?
Yes.
Oh, I deeply apologize. I forgot to show you something. I drew it up here and I was thinking, but I got sidetracked. My bad. This is the sample space. Yes, no? I outlined these two, but I forgot to. I was going to tell you that I was using the corners of the whiteboard for the outline of the sample space. In a Venn diagram, you have to outline the sample space. You have to. If you don't, if we didn't put these lines around it, then the sample space is this whole board. Okay? You have to outline the sample space. Okay? In some cases, you won't have any area outside the sample space. In other words, you might have a Venn diagram that looks like this. Where this is A, this is B, and this is C. Well, there's no area outside the sample space, is there? Right? Talk to me. Does everybody see that?
Right.
Every single square micron of the sample space outlined in the outer rectangle. Each point in the sample space belongs to either A, B, and or C, right? Because we have the intersection of all three as well. Okay, that's important to note. Really important to note. Do you see the importance of outlining the sample space?
Can I phrase it another way?
Absolutely.
It's for those that haven't taken discrete math, it's important to define your universe of discourse, which is just
Okay.
another word for the sample space, because it's the same as defining the population. If you don't do it, then it could just be anyone, where we limited our sample space to be students. It's the same thing, just graphical.
The what? Kind of. Yeah, actually, that's a term frequently used with stats when we get into functions. Okay, yeah, absolutely. You can think of it in the same terms. Yeah, works. Okay, now, are there any questions what we've done so far? What's the probability that we pull some guy or gal? We ask them, what class are you taking? Taking an arts class? Yeah. Taking a math class? Yeah. Taking a tech class? No. What's the probability that if we ask someone, they're taking at least one of these areas? For example, and you say, well, what other types are? Well, if it's a business major, there's actually a reasonable probability, not close to zero. There's a reasonable probability that they're not taking any types of these classes, right? Right. My son-in-law is a business major. I'm sure there were semesters where he didn't take any of this stuff. He did business plans and business proposals and stuff like that. I have no idea. I have no desire to be in business. Anyway, so we're finding the union here. Okay. All right. Now, looking at the Venn diagram, how do we do that? Well, when we did the union of two events, what we did was we said, okay, we're counting all of the individual outcomes that are in one event or the other event, either one or both, right? That's how we defined it. And you say, well, why do we subtract out the both? Because when we add the probability of A to the probability of T in this example, we're adding both twice. So we got to subtract one of them out. Okay. That's all review. Yes, no?
Mm-hmm.
Right? That's all review. So when we do the probability of three, the union of three events, it's we could do the same set theory proof. I'm not going to do it because it would make my brain hurt. But Venn diagram wise, I really hope it's fairly easy to talk you guys through it. Okay. The union is this rose petal color shaped thing, right? Right?
Yes.
Okay. So we're adding the probability of A to the probability of T to the probability of M, right? We got to start there. Yes, no?
Yes.
Do you see that? Does anyone not see that? Talk to me. We're good? So we got that. Now, what's the problem? Well, we added the three footballs twice. Yes, no? We added this area here twice because it's in A and it's also in M. So we added A plus M. We got to subtract it out once. Yes, no? Does everybody see that?
Yeah.
Don't worry about the intersection of all three. We're going to take care of that. So we have to do that three times, don't we? With each of the three football-shaped intersections. Do you see that? Talk to me.
Yes.
Yeah.
We got to subtract this out, and we got to subtract this out. Okay, so we got to subtract. And hopefully some of you are already seeing what we're going to do at the end. What are we going to do at the end to make things right? We added this area in twice. We subtracted it out once. Okay. So that handles that, but we so it's actually not the intersection of all three. We added it what do you call it, Brian?
Rouleau triangle?
Rouleau triangle. We added the Rouleau triangle twice, or three times actually, because it's part of A, part of T, part of M. We added it in three times, but we subtracted it out three times because it's also part of the three footballs. Do you see that? We added it in three times, we took it out three times, so we have to add it back in once. From the Venn diagram, does everybody understand that? Talk to me.
I think the diagram helps.
Yeah.
It really does. Yeah, it does. We could prove this using statement and reason proofs using set theory arithmetic. We could, but
I think I hung up.
Guys, we're engineers. We're graphical, right? We're graphical based. Most of you are. I am.
I'll hang it up.
I can read a paragraph 5 times before I understand it, but
Okay, thanks.
if I have a diagram, I can understand it in like 5 or 10 seconds. I don't know if anybody else is like that, but I am. Okay. Yep. Most engineers are. So, what's that? Yeah. Yeah, actual doing. Okay, I'm going to use green because we haven't used green yet. What's the probability of A, guys? You got to give me these numbers.
0.4.
What's the probability of T?
0.5.
Probability of M?
0.6.
Probability of the intersection of A and M?
0.22.
Probability of A and T?
0.15.
Probability of M and T? Wasn't that pretty high?
0.37.
Plus, we have to add the probability of all three back in, which was 00 or single 05, right?
Correct.
What do you get? Hopefully it's not negative. I don't think it is. 1.5 minus 0.55. It's not negative.
I got 0.81.
81?
That's what I
Yeah.
got too.
Does that number make sense? Did we screw anything up? I don't think we did. The probability of the union has to exceed all three of these unions, yes, no? Probability of the union of all three has to exceed each one of these by inspection, right? Because we're adding area,
Mm-hmm.
right? So yeah, it works. Now, you ready to have some fun with some of the other problems you're going to encounter in life? Using these same numbers, same problem, same everything. What's the probability that a randomly selected student isn't taking any one of these courses? Types of courses, I should say.
So that would be 1. Well, the sample space minus the what's it called? Of all
Union.
three. Yeah.
Union. So you use that theorem we developed the other day, right? Instead of figuring out the hard way, just subtract the inverse, right? Probability of the inverse out, yes, no? Say yes, Brian, that's what you did.
Oh, sorry. I was writing down. Yeah.
Probability of sample space is 1. That's by axiom 2. Correct?
Yeah. Yeah, 2.
Minus, what's the union of all three? Didn't we just find it, guys? So there's a 0.19 probability that a randomly selected student is going to say, you know, I'm just taking underwater basket weaving plus business courses. You know, I'm not taking anything arts, technology, or math related. Not that underwater basket weaving doesn't have its. Do you guys use that analogy anymore?
I've started using that. I've picked it up.
Have you?
Yeah.
We used to say that all the time because back in the, you know, the problem. Well, I don't know if you know the problem. Problems with college athletics. You hear all these horrible stories about some superstar at like Alabama or Auburn or especially Ohio State. You know, somebody's in trouble because of this, that, or the other thing. you find out that their tutors are taking exams for them, that kind of thing. Just all sorts of academic violations, all sorts. It was really bad in the 80s and 90s, believe it or not. It still is pretty rampant. But so anyway, we used to joke that, the Ohio State football team specializes in underwater basket weaving as a major. Anyway, we were mean. If you're studying underwater basket weaving at Ohio State, I apologize. Okay, I didn't mean to offend you.
It's an honest living.
Well, yeah, I'm not sure there's a lot of market for baskets that are woven underwater, though. Anyway, but if you could sell them, it'd be an honest living, and that's more than fine. Okay, ready for a few more? You want to do a few more before we call it a week?
Yeah.
Ready to roll? Other than Brian, anyone else?
Yep. Also got 10 minutes left.
Thank you very much. I'm gonna add our little scorecard over here so I can erase this. We're gonna leave the Venn diagram because I think you guys respond to it well. So, probability of arts or mathematics equals what? Talk to me. 7.8.
7.8. Yeah.
Probability of arts union technology. What's that?
0.75.
Is the other one 7.3?
Yes.
I can remember numbers, but I can't remember to pick up a loaf of bread on the way home. Anyway, probability of all three is 8.1. Yes, no?
Yep.
So we can erase this. We also know the probability of none is just the inverse of the probability of the union of all three. What's the probability? And I'm going to phrase it in English, and we're going to have to convert it into set notation followed by the actual calculation, okay? Because this is how you're going to see things given to you in real life. What's the probability that a randomly selected student takes math and a technology course, but no arts? Now, there's two ways we can go about converting this into something we can work with in terms of set notation and therefore easily convert it to probability. We can do it using the statement and the definitions of intersection, complement, and union. Or we can go over to the Venn diagram, figure out what area we're talking about, and then figuring out the set expression and therefore the probability from there. Okay, so there's two ways to do it. Let's do it just by looking at it. Okay, and then we'll compare what we get to the Venn diagram, make sure they agree. Does that sound like a plan?
Sure.
Everybody okay? Is the boat rocking for anybody? We good?
Good.
Okay. So this equals the probability. Clearly, we need math, do we not?
Yes.
Right? And the word between M and T is and, so that implies intersection or union.
Intersection.
Definitely intersection. Now, what about the arts? How does that fit in? Well, looking at the statement, does anyone want to take a guess? Would it be intersection? And we have no arts, so it's going to be a complement, will it not?
Yeah, I was going to say it would be an intersection with not a.
Why do you say that, Brian?
Because
why not union?
I don't know how to verbalize it, honestly.
It would say or no arts if it were union, wouldn't it? The word but.
Right.
Could we replace but with and not change the context of the statement? Could we do that?
Yes.
Now it's pretty clear it's an intersection all the way down, isn't it? Do you see that?
Yeah.
Math
Is there another
and
way
technology
to think about
and
that?
I'm sorry?
Is there another way to convert the words into an expression?
You just got to look at it. I'm sorry.
I always struggle with that.
Most engineers do. That's why we have Venn diagrams. You want to take a look at the Venn diagram, make sure we're all on the same page?
Yeah.
Let's do that. So, math and technology. Doesn't that imply that we are automatically in the football, right? We're in, I'm going to try to draw it without jacking up the diagram too bad. That's not right. Let me do it in dark, and I think this is teal. Math and technology automatically places us inside this football. Yes, no? Talk to me.
Yeah.
Everybody, does anyone not understand that? Everybody good?
Yeah.
But they can't take arts, right? Whether you use the word but or the word and, they both say the same thing. The student can't be taking an arts class. Do you see that? Yeah, we have to subtract out the intersection of all three, because the intersection of all three is arts, or let me rephrase it. The intersection of all three is math and technology and arts. We clearly don't have that. We have no arts. Therefore, we need this. Maybe there's a name for this figure here. I don't know. Oh, and I am totally jacking up the diagram.
An ice cream cone.
Yeah, actually, yeah. What color can I use? I can use red, right? Because in this figure, in this little ice cream cone thing, right? We need this. So does everybody see, does anybody not see that, do you see how that expression actually is set theory? If I ask, does everybody see, that's the complement of does anyone not see, right? I think. Anyway. What's the area of that red thing? Math, intersect technology, right? That's the football. We got to subtract off what? Talk to me.
Okay.
How about the intersection of all three? Because remember, we are starting with the football. And the only part of A that is part of the football is the intersection of all three. Do you see that?
Yeah.
Okay. Very good. Good job. And what do we get? What kind of numbers do we get?
It's 0.37 minus 0.05, which gives you 0.32.
Okay. Wow, we're out of time. All right. Are there any questions on this? Talk to me.
In my notes, I put take the triangle out of the football to make an ice cream cone.
If that works for you, Brian, I am 100% in favor of your notes.
I like it.
I do too. Any questions, guys? Talk to me. Okay. Hearing nothing, it's 5:20. Let's call it a day. All right. Everybody good?
Yes.
I think so.
Okay.
Yep.
Take a look at the homework, okay? We've covered enough material, I think, for you to do all of it, I think. Okay?
Yep.
Let me know. Please take a look at the homework seriously, and you can bring any questions on Tuesday, okay?
Thank
all right.
you.
Yeah.
Mm-hmm.
Certainly don't struggle with it, that's for sure. All right. See you on Tuesday, guys. Have a good weekend.
Thank you.
Thank you.
All right.